All right, guys, just a quick lesson on metric system and unit conversions. So the metric system, oh, by the way, you can pause this all you want. You can make notes on this if you want. You could also, this one I'm giving you the option of just following along. It might help you to use a calculator though. You'll have to go back and view this to do the short, tiny little assignment that goes with this. So it's up to you. All right, so the metric system is an international system of measurement. All the units are multiples of 10. And the base units are meters for length, grams for mass, liters for volume, or centimeters cubed, and when we're doing density. Seconds are for time, bytes are for computer memory, and watts are for power. Now, in this course for chemistry, we really don't need to use those two, but they are standard units of measurement. So the first thing I have to go over with you is what are these symbols and what do they mean? So giga, like for example, a gigagram or a gigabyte, has the symbol capital G, and it means that it's times 10 to the power of 9 is the relationship to the base unit, and that's 1 billion. That 10 to the power of 9 is 1 with 9 zeros. 1, 2, 3, 4, 5, 6. Move myself out of the way. 7, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm not going to write that out for each and every one of these, but that is what that means. Mega has the symbol capital M, and it's times 10 to the power of 6, which is a million. And if you are writing this down, you don't have to write down that that's a million, but that's what it is. That's what that exponent means when you put it on a 10. It tells you how many zeros are on the number. So a 1 with 9 zeros, a 1 with 6 zeros. And then kilo is a lowercase k times 10 to the power of 3, which is equal to, that's what these should be. Hopefully you guys aren't writing that down as I suggested. Equal to, is equal to 1,000, 10 to the power of 3 zeros. Hecto is a lowercase h, and it's times 10 to the power of 2, which is equal to 100. Deca is actually dA, and it's times 10 to the power of 1, which is a real nerdy way of saying just 10. And then you have your base unit, which has no prefix on it. So this is where your grams or your liters or your meters for lengths, stuff like that would go in. All right. You don't have to write that in there. 10 to the power of 0 is equal to 1. And then we get into the small ones. You'll notice now all the exponents on the tens are negative. So deci is just a lowercase d, and 10 to the power of negative 1 is 0.1. So now the exponent, when it's negative, means how many spots in front of the 1 does that decimal go? Centa is a lowercase c, times 10 to the power of negative 2 is 0.01. Mille is a lowercase m times 10 to the power of negative 3, and it's equal to 0.001. Micro, now the symbols do get a little strange. Micro is actually a funny looking U. It's a U with a little tail on the left-hand side. And it's times 10 to the power of negative 6. Will I be able to fit this? I got to go 1, 2, 3, 4, 5, 6. 2, 3, 4, 5. Yeah, that's right. So the decimal is 6 places over from the right side of the 1. The symbol is that funky looking U. Nanos is not too bad. It's just a lowercase n times 10 to the negative 9. And that's going to be 0.1, 2, 3, 4, 5, 6, 7, 8, 9. 1 billionth. A nanometer is 1 billionth of a meter. It would take 1 billion nanometers to make a meter. All right, so there's the table. Those are your conversion factors. If you know how to use exponents on your calculator, it can be very handy. If not, you got to use these larger versions I wrote out on the right. So as a helpful hint when we're converting, as the unit increases, the number gets smaller, and as the unit decreases, the number gets larger. So if I'm going to show you what to do here. So it says convert 514 kilograms to grams. Kilograms to grams. So what you do is you look on the table. And I look where I'm going from. I'm going from kilograms to grams. Grams has no prefix on it, so it's just the base unit, grams, like that. So when I'm going kilograms to grams, what is my difference in power of 10? Let me just change up my color here to a highlighter. I'm going from a 10 to the 3 to a 10 to the 0. And the difference there is what's important, the difference. So 10 to the 3 to 10 to the 0 has a difference of a power of 10 to the power of 3. So I'm going to write times 10 to the power of 3. Now, if you don't know how to use exponents on your calculator, you will have to type that in as 514 times 1,000 because that's what 10 to the 3 equals. So the answer is 514,000 grams. Try typing that into your calculator and making sure you can get it. Next, it wants us to convert to milligrams. So let's take our newly found number here, the 514,000 grams, and try and convert it to milligrams, grams to milligrams. So let's go back to our table. Grams is here, and we're going to milligrams, so that is down here. Milli is the small m, so I'm going from a power of 10 to the 0 to a power of 10 to the negative 3. What is that difference again? Now you might think, well, that's pretty easy. It's just it's 10 to the power of negative 3 difference. But no, that's not true. When you're going down the list, I want to get rid of that. When you're going down the list, you always get a positive exponent. And when you're going up the list, you get a negative exponent. Maybe I can write that somewhere. I can write it right here. When you're going up the list, you get a negative exponent. So if I go over, what did I say my difference was? When I'm going from 0 to negative 3, the difference is 3. And it's going to be 10 to the positive 3 again because we're going down the list. So if I multiply 514,000 times 1,000 again, or 10 to the power of 3, I'm going to get 5. Ooh, that's an ugly looking 5. I'm going to have 5, 1, 4, 0, 0, 0, and then 0, 0, 0 again. Think about that one. Type it into your calculator. Make sure it makes sense. Go back and watch the part of the video where I went down the list. And let's go do one and go the other way when you're ready. So I have, what is this? 578,230 centimeters. I'm going to convert that to meters. Centimeters to meters. So I'm actually going to erase some of the stuff I did in the last example. If you guys wanted some of that written down, you can go back and write it down, or you maybe already have it written down. I'm going from centa to no prefix. So just to regular grams, I believe it is. Let me double check. No, meters. I'm going from centimeters to meters. I'm going up the list, so I know it's going to be a negative exponent. And I'm going from negative 2 to 0. Let me just take away my highlights from the last example so I can highlight what we're doing this time. When we're going from, I don't know why that zoomed out, but it did. We're going from negative 2 to 0. So the difference is 10 to the power of 2, but since we're going up the list, it's going to be a negative 2. So I'm going to write times 10 to the power of negative 2. Now again, if you don't like using exponents, what's 10 to the power of negative 2? It's 0.01. So you could also write this as times 0.01. It's going to equal 5782.30. Now I'm going to show you a way to cheat the system in a minute after we do the last one here. Meters to kilometers. Back to my list. So no prefix, So right here, up to kilometers. So I'm going from a 0 to a 10 to the 3, right here. I'm going up the list, so it's going to be a negative exponent. What's the difference between 0 and 3? Well, it's 3. So it's going to be 10 to the power of 3, but negative 3 because we went up the list. 10 to the power of negative 3. Again, you can look at what the actual decimal is if you don't like using exponents. So that's going to be 5 decimal 78230. Now, if you do this on your calculator, it might not show you that 0 on the end. Same with this one here. That's okay. That's just a place. It's not even a placeholder. It's a trailing 0, so calculators don't seem to like those. It's still right if you leave that 0 off. So that's the answer. I am going to show you a little cheat here. I'm just going to change my color to blue. What did I actually do? 578230, technically there's a decimal at the end of that number, and when I go times 10 to the negative 2, it moves the decimal 2 places. And you see where it is now, it's between the 2 and the 3. And then on the last part, I went times 10 to the power of negative 3, and how many places did I move my decimal? 1, 2, 3, right between the 5 and the 7, which is where it landed. You can apply the same logic to the first example we did. The decimal's at the end of the 514, and we moved it 1, 2, 3 places. Now, when you're moving it this way, you got to fill in those spaces with 0, because how are you going to put a decimal out there by itself? Same with when we did the last part, the decimal's at the end of the number, times 10 to the power of 3, 1, 2, 3, means I just added these 3 zeros on. So I've given you a number of different things that you can do to solve these. If you're absolutely lost, this isn't going to save you on an in-class test or anything like that as you move forward in science and physics and chemistry, but if you just Google unit converter online, that'll help you convert units too, or at least check your answers, okay? So I'm going to do a few of these with you. It says indicate with an arrow which direction the decimal moves and by how many places. All right, so kilometers to meters. Kilometers, I'm not even going to go back to the list now. It's 10 to the power of 3 to 10 to the power of 0. Because there's no prefixes, 10 to the power of 0. What's the difference? It's 3. So I'm going to write, I'm going to say moves 3 places. And which way does it move? It moves this way. Makes the number bigger. Centimeters to meters, that's 10 to the power of negative 2, 10 to the power of 0. So that's 2 places. In this case, it's moving up the list. So it's 2 places. The other way. Liters to centiliters, 10 to the power of 0 to 10 to the power of negative 2. This time we're going down the list, so it's still 2 places. But this time it's this way because we're going down the list. Kilograms, 10 to the power of 3 to hectograms. That one I never use. I always have to look it up to make sure. Hecto, 10 to the power of 2. To 10 to the power of 2, we're going down the list, so the difference is 1. So it's going to be 1 place. And we're going down the list, so it's to the right. Just so if you're wondering, like, what the heck do you mean by 1 place and to the right and stuff like that? Let's say it was 11 kilograms. Well, it would equal 11 or 110 hectograms. I took the decimal at the end of the 11 and moved it over 1 and stuck in a 0. Kiloliters, actually, I got to erase that. So if you wanted to add that, you'll have to pause the video or go back and pause it and get it. So kilo is times 10 to the 3, and centa is times 10 to the negative 2. Now we have to know a little bit about integers and if you've taken grade 9 math, you'll have a bit of an advantage here. What's the difference between 3 and negative 2? Well, you can envision a number line if you want. 0 in the middle, and we go 1, 2, 3, 1, 2, 3, and then we go negative 1, negative 2. So what's the difference between 3 and negative 2? How many? It's 5. 5 places. And what are we doing? We're going down the list, so it's moving to the right. Number 9, we're going no prefix, I should say, 10 to the power of 0 to megameters. That's 10 to the power of 6. Capital M is mega. So the difference is 6, so we're going to say 6 places. And in this case, we're going up the list, so that means the decimal is going to move to the left. Now, there are some more here, which if there's those of you that need more practice just figuring out how many decimal places things move, then I can help you with that. But I wasn't planning on taking those ones up unless we need it. These ones down here, make each conversion, is for you to do. I'll do the first one for you. So we're trying to go from centimeters, 10 to the power negative 2, to meters, 10 to the power of 0. The difference is 2. But which way do we move it? Going from 10 to the negative 2 or from centa up to no prefix is going up the list. So it's going to have a negative exponent, or you're going to move the decimal to the left. 1, 2. So 0.08 meters is the answer. The way I showed you how to do those first ones, you would just multiply the 8 times 10 to the power of negative 2, and that would give you the 0.08, or times it by 0.01. That would give you the 0.08. But I'm not going to do the rest of these with you right now because it's a very short assignment if you know what you're doing. If you don't, then it can be a little bit painful, but I will help you with it if you come on and ask for help. So I know you guys can't type or write into this document very easily. So what did I do here? I copied these into a document, a Google Doc called Conversions Practice. So there's a couple of things I want you to do here. I want you to just do the conversions and just type in the answers. And I also want you to state whether it's measuring mass or volume. Is this a mass or is this a volume? All right, so you can just type that underneath. So the first one I'll do for you. Did I type that out right? Let's have a look. I'm going to go back here. I just all of a sudden feel like I have the wrong thing in there. It's 8 centimeters to meters. Let's go back and make sure I have that right. Conversions practice, 8 centimeters to meters. Meters, there we go, lowercase. You can't convert centimeters to kilograms. That would make no sense. That's converting a length to something else. So this is where you would type in the 0.08, 0.08. There we go. And then underneath it, what are we measuring? Mass or volume or length. I should add that. So that's because this first one is length. Mass or volume or length. I think that covers them all. Yep. So mass, volume, or length. And that first one's length. So that's the answer to the first one. You guys go ahead and do the rest of them. I'm going to scan it since I had a couple of typos in this thing that I got together quickly. No, I think the rest is good. I think that the rest is good, so I'm going to close that off. And you guys do that. I only have allotted 10 minutes for it, but if it takes you longer than that, it's no big deal. Block 1's pretty long anyways. And then the only other thing you have to do is the units of measurement practice, which I think will take you around 20 minutes. Now, this one I didn't type into a Google Doc. It's got 40 questions, but all you have to do is state with the number. For example, actually, let's take a screen shot of this so I can look at it with you. Here it comes. There we go. Let's make it full screen. There it is. So the first one says a Bunsen burner uses about 10 liters of air for every 1 liter of gas. So the question is just asking you to write, well, what is that? Is the underlined quantity 10 liters and 1 liter, is that a mass, a length, an area, a volume, a temperature, a time, or a density? All right, so the first one is volume. That's all I'm looking for there. Number one is volume. Number two, the test tube contained 15 grams of crystals. Grams. That is a mass. Let me find an example of a few of the other ones. Centimeters squared, anytime you see that it's squared, that's an area. That's not really one that we need for chemistry, but that's all right. Centimeters cubed is always a volume. I wanted to find one with density because later today I'm going to teach you about density. So there might be one on the other side there. Let me just have a look at it. Classwork, yeah, right here. So let's move it over, and I just want to see if there's any. So in the second set, you know what? I don't even need you to do that. I'm changing things on the fly. I just want you to do 1 to 20 right here. All right. The second set of 20 questions asks you to estimate what you would measure various things in. Like the mass of a penny would be about 2.5 what, and you have to put in a prefix with the number. But I don't need you to do that. The whole point of this exercise is just recognizing that liters is volume, grams is mass, centimeters is a length, and so on and so forth. Number 14 down there. I guess I didn't have 14 on my screenshot. So we'll go to it. So 14 is an example of density. And the reason is that it's grams per milliliter. So let me just zoom on that even a little more closely. Grams per milliliter. So if you have a mass per a volume, that represents a density. And we'll learn more about that later on. But for now, that's how you can identify it. So all I'm looking for is you to put the numbers 1 to 20. And beside it, just write what the measurement is. For example, number 1 is a volume, number 2 is a mass. So just do 1 to 20. Don't worry about the second set of 1 to 20. I think that'll keep you busy enough, and you'll have learned what I wanted you to learn. All right, I think that covers the entire block. Yes, it does. Mass and volume lesson is covered. We've got our conversions practice, and I think we are good to go. Okay, guys, I'll stay on the Google Meets. And you guys can come on and ask me questions as you need them. As it's a kind of a basic math lesson, I suspect that a lot of you will come on and ask me if things are right or wrong, okay? All right, I look forward to hearing from you.